you don't really understand the impact of change. Information doesn't get spread across the organization effectively. And you find out a lot about what systems engineering is, and specifically MBSE. It ends up about addressing communication and making sure that information is available to everybody, and collaboration. And the whole idea, or a lot of the idea behind it is, so they talk about hardware, software integration, software late. And this is because people are pushing out requirements. It's how many requirements did you deliver over this time period? That tends to be the benchmark in a lot of organizations. And it's moving away from that to actually understanding what those requirements do and the impact of those requirements, which is where we start to reduce any issues or problems that we can find. It's basically about finding problems earlier. So basically it's reducing rework, it's reducing risk. And that's what we're trying to do with the models effectively. The other thing is many organizations lack formalized practices and processes. These really do need to be brought forward and applied strongly. And also workforces losing, well, aging workforce, losing a lot of expertise. And the size of projects is just becoming more and more complex. So we've got to find ways to manage that. You'll hear a lot of talk about requirements. Basically, requirements are important because how do you know what you're going to be delivering? So they need to be well defined, and you end up with these requirement structures that link user requirements, technical requirements, this down to design and down to test cases, which is where you do your V&V. And this is an information model that goes across the V cycle, which I thought you'll start to become very familiar with if you aren't already. But you need this traceability to understand the impact of change and how that change is going to be propagated through a design, and then how you're going to test it. And so when we talk MBSE, it's not just about the models, which we're going to talk about in a minute, but it's about that digital thread and that digital engineering that you're going to create as a result of building those models in a digital environment. So when you're doing requirements, it's about having a data model and information model, which is what MBSE again. So when you have models, it means that you can start to query your understanding about what they are, understand the relationships that exist between things, find missing links. A key thing that you'll find with requirements engineering is they start talking about coverage analysis. Okay, how is this higher level requirement met? How is it met in the model? How is that going to be implemented further down the line? Is it split between hardware, software, or how do you break out a function and then decompose it across different pieces of equipment? And that is not only just relevant for the requirements, but it's also relevant for the models as well. Again, it helps with that impact analysis. So I'm not of the camp that says you're either doing requirements or you're doing models, and neither of the two shall mix. Basically, requirements and models work together. So the ways that people tend to think about, one of the ways that we can do that is we can think about graphical abstractions, understanding what's going on, and we've got circuit diagrams, you've got atomic charts, you've got some 3D CAD there, noise, plans, whatever. Okay, that's one way of seeing the world. But that's not so easy where people are talking around, normally around around software systems, which is where a lot of MBSE started. Typically for software systems, you get a requirement that's like that. Okay, it's a bunch of words that describes a sequence, and that you've got to spend quite a bit of time to parse it and understand it. But really, that can be abstracted into something like a sequence diagram. Okay, that sequence diagram talks about how two different threads of behaviors work together and the messages that go between them, and it gives you some timing information, and it starts to become very clear. Okay, so that's one of the reasons why we start to use models, and in particular this is based upon SysML, so SysML sequence diagram. But we can start to abstract work breakdown structures, component structures. We can think functionally, i.e. what does the system have to do, and then we can do the allocation as to how, and we can treat both of these abstract views of the world as an understanding about what we're doing. The other thing that we do with models is, I always say the model is the memory. Okay, classic paper 7 plus or minus 2 comes from the 50s, is about how many different threads of information you can manage in your head. I think it sort of gets abused a bit, but basically the complexity of systems nowadays, you cannot understand everything that's going on at once, and so the model becomes your memory. It becomes a reflection of your understanding and of your organization's understanding about what systems are doing and how they work, and that cannot be easily captured in text, despite the fact that that's still how people seem to think it can be done. Okay, text can be it can be twisted and it can be misunderstood so very easily. So the models become a more defined, formal way of understanding what's going on. So typically what you'd see is this big pile of paper. What we want to see are things like activity diagrams. That's basically what this is, that have been mapped to swim lanes, different parts of the system, so you can show the different messaging that maps directly onto your interfaces. You can start to define interfaces from that. It becomes very easy to see, or you can run some sort of analysis on it. As part of my career, I worked on Eurofighter, and you'd find big boxes of paper lying around, and they would end up going to somewhere called Iron Mountain, which is a huge warehouse just north of the M6, or sorry, just north of Manchester, and thousands of pieces of paper would end up in there because they wanted some physical storage of it. And it's to get away from that and to go towards this more model-centric digital way of capturing systems behavior. That's what we do with MBSE. So this is just another way of dealing with it. So it's taken a simple context diagram, and I think this one's just been imported into DAWs, but that can be captured within a model in its own right, or that would be captured within a, say, a Rhapsody or Magic Draw model, for instance. But with a model, it's more than a diagram or a set of diagrams. It's a set of interrelated data elements, but how they're brought together gives you an understanding about, it's a reflection of your process, and it's a reflection of the traceability, and basically it helps communicate ideas and consistency. Okay, the big thing about having a model in a digital environment is that it should be consistent, complete, and what's the other C? I used to say, yeah, it's consistent, complete, and there's another one I can't remember, but basically everything should come together and it should be whole and accurate. So how does it help? So model-driven systems development basically provides a visual approach to refining requirements in a robust system. We have the V process. This is like high level view of Harmony from when I used to do that, but it basically shows you that there is this V process and there's an information model that sits underneath it, and your model sits in the repository, but it's being seen by all aspects or different parts of the design. At the top there, we got the systems engineering part, and then you've got the software engineering part, because that's what we were mainly dealing with at the time. But you can pretty much fit with any type of discipline. But it really helps you understand what your requirements are, how they map to different parts of the implementation, how they're implemented, and then how they're actually fulfilled and managed as tests. And it's so ultimately ends up about being or improving communication among stakeholders, and gives you that disciplined process to develop whatever you're developing. One of the areas that we look at it's not just maybe just about understanding a set of requirements. We can use it to do analysis. So part of my PhD was about doing options analysis, and we can do this with models. It's about understanding the trade-off between conflicting stakeholder requirements. I don't know how many times I've seen a set of requirements that say things that are at odds to each other and totally mutually exclusive, and it becomes a way to understand really what is important to the customer, because you force them to make that decision about it, really, or someone is forced to make a decision somewhere along the line, and then you have that traceability. So typical one, speed and fuel economy. So a lot of stuff that I did was around simulation or using models for simulation. That can be hard to do because they need to be fairly accurate. You need really good interface definitions. You need to understand behavioral languages, but they give you a lot of value in the end, basically because they can help you with things like trade studies, but it helps make sure that things like safety critical, that you've got the right behaviors. What happens if this piece of the system goes down, or if I get the wrong signal? It allows you to do that analysis, and it allows you to understand what will happen. And you'll hear this a lot in systems engineering. A lot of what we do is left shifting. It's the idea of doing more analysis up front, and part of that is about the model execution. Basically, it costs you like 2 or 3 times the cost of an issue to fix it earlier on in the development, compared to about 1,000 times later on when you basically got to make that fix on something that's going through a systems integration testing, and you find an error that exists when you're trying to plug 2 things together and they don't work. Now you've got to make some change, and that could have huge impact across your design, your implementation, your development, all sorts of things. So a lot of what we're doing is trying to use models to left shift, understand the problems that before we even actually put them into the implementation and the effects. So
just as a quick check for time, yep. Graham, we're going to have to at this point just quickly move on to Geoff's section, but perhaps we can circle back around to this at the end when we come to the closing thoughts.
I thought you gave me 45 minutes. That's what I was going to do.
It was meant to be
20.
It was meant to be 30. Apologies.
Should have mentioned that. But, there's a load of stuff there around why does it matter.
What we can do is distribute. We can distribute some of these slides out.
Yeah, and there's a load of useful links there. Okay.
Okay.
Sorry.
Well, apologies for the confusion there, Graham.
Yeah. Okay. Do you want to?
Geoff, do you want to start sharing what you've got?
Yeah, absolutely. Thanks for that. And yeah, I'm sure Graham will be picking up on things that'll overlap. Yeah. So feel free to jump in as you see fit.
Yeah.
Okay.
Just take the screen and stop.
Just let me know when that comes through, Nathan.
Yeah, I've got that up on the screen.
Fantastic.
So this section is going to be a little bit more conversational. So think of it a bit more as an interview. So first things first, Geoff, would you like to introduce yourself, who you are?
Yes, yeah, can do. So, hi everyone, Geoff Cooke. I work as a systems engineer for Atkins, member of S&C Leveling Group, and I've kind of been working at Atkins for about 6 years now. Joined as a graduate in 2017, and prior to that, I did a master's in mechanical engineering. So again, one of those systems engineers that kind of started out in a different field and found their way through the work they were doing to be more aligned with systems. So I did a few summer placements during my time at university, and that was very mechanical engineering oriented. So with Network Rail on some of the signal and infrastructure projects. I worked in R&D at Caterpillar for a summer on, again, it was a kind of organic Rankine cycle R&D program. So looking to improve engine efficiency through waste heat recovery. And I did a summer placement as a field engineer in the oil and gas industry. And that was, again, very hands-on mechanical engineering type role. And then within Atkins, I've been working kind of mainly as a systems engineer within the kind of fluid mechanical systems team. So that started off. So I worked initially working in the air-to-air refueling project. So that was for a couple of years. That was developing requirement sets for kind of fuel transfer systems for an air defense program and doing some V&V. And that was very kind of, although we were using models, it was text-based models, and it was, you know, we had a source of truth, but the MBSE maturity was fairly low on the program. And we used those to develop verification reports and generate evidence to support certification for a program. I then moved on to a mechanical engineering role on a construction program, and then more recently been working within the submarine and air defence domains, mainly working on qualification planning, kind of high level type roles, and more recently looking at kind of digital engineering strategy in the air domain. So that's kind of trying to work out how does a complex future air program look to do its digital engineering, and within that MBSE obviously sits.
So it sounds like you're reasonably new to systems engineering as a profession, Geoff, if I'm right.
Yes, yeah, definitely kind of consider myself as an early career. So although I'm chartered as a systems engineer, my experience within MBSE is limited. So looking at it very much from the kind of the problems that we see with our clients on programs, and identifying areas where we can be applying MBSE perhaps better, but also making sure that we're engaging with the right stakeholders and really kind of getting to the crux of why we're doing MBSE and getting the purpose of it clear, so that we can actually realize the benefits of it, which is, I think, so much of the challenge.
Sure. If you quantify in terms of, you know, weeks, months, years, how long would you say you've spent on MBSE?
So within again, different maturity levels of MBSE, full-blown automation of our modeling and doing requirements and architecture, system analysis, and that sort, and working in a program that leverages all of that completely. I've not got any experience of that. However, in terms of the lower levels of maturity of MBSE, I'd say I've got a couple of years of experience of engaging with programs that are using it. Actually applying it myself, only a few months, I would say, in total.
Sure. Well, sounds like you've got a lot to relate to a lot of people on this call.
Yeah.
Are there any of these projects that you're able to go into a bit more detail about? Give some examples.
Yeah, sure. So the current program I'm working on, it's still very much in the early phases. So we're at the concept and assessment stage of a kind of future combat air program. And it's a really interesting international context that we have to work in, and there's a lot of ambition to leverage digital technologies across the program and not just within engineering. And within that context, working out how do the different engineering capabilities need to interact in order to leverage, you know, the capabilities of the partners most effectively to actually deliver the vision of the program. So there's a complex kind of international kind of industry government relationship that needs to be developed. There's the program itself in terms of reference as kind of organizations. How do we work? before we even get to the data, the model-based approaches to how we do engineering. So we're at that stage where we're still forming the program organization whilst also kind of developing the capabilities, MBSE being one of them. So it's a really complex problem, and we're starting to converge on kind of approaches for different areas. And within MBSE, there's a real challenge around how do we manage, say, the kind of federation of the models that we're kind of developing at the moment. How do we enable the right capabilities at the right time for the program? So working, with the kind of the complete vision and timescales. How do we essentially ensure that the program has the right level of MBSE capability at the right point? And actually, what's the point of us doing MBSE, right? So, a lot of the value that we see in doing MBSE is, as Graham pointed out, it's left shifting risk reduction as much as actually being able to utilize the digital threads and the data that we establish in the models to support through life. And it's articulating that business case of doing MBSE appropriately and digital engineering in a holistic way, that I still feel we have a real challenge to try and get to the bottom of.
You've mentioned digital engineering there. It's a sort of buzzword I've heard before, but I wouldn't say I thoroughly understand. My mind would immediately go to, that means model-based. Is there a difference between digital engineering and model-based systems engineering? Do the two overlap, or what?
Yeah, there's loads of kind of different thoughts on it, but in terms of, I guess, my perspective on what digital engineering is, it's still engineering. So complex programs typically that I've got experience in, there's lots of different engineering disciplines involved. So you could have your mechanical engineers, electrical engineers, systems engineers being involved, software, and you've got through life support, you've got safety. So they've all got their capabilities. So how do we collectively leverage digital approaches to delivering that capability in a way that actually improves our efficiency, improves our speed, reduces overall cost? And model-based systems engineering previously, define a model. We've kind of made explicit that it has to be data that's driving the engineering when we go into digital engineering, whereas MBSE could technically not be data. It could be diagrams.
Sure.
So, and then there's and this is where people's definition of MBSE comes in. So I agree. I agree that it isn't, but I've heard people explain MBSE in different ways. So I think with digital engineering and model-based systems engineering, the way it's going, it's all being driven by data. So MBSE, as I see it, is that kind of structure on which we need to be interfacing and interacting with the different engineering capabilities and supporting the program delivery through life. So, you need to be thinking about how you're going to be supporting your systems when you're developing the architecture, so that you are kind of creating the right frameworks to be able to actually manage that more efficiently. So there's a lot of stakeholders to be involved, particularly early on in the system lifecycle, whereas previously they may have been considered later on.
Yeah, I mean, I completely agree with it. It sounds you're working on FCAS, aren't you, and Tempest, by the sound of it, because I had a little bit of interaction with them as well. But one of the key things is, I think MBSE forces, if you do it properly, it's more than the models. It's about how you time the models, the tests, the requirements, how you manage all that, and how you manage the interfaces, as you said, to the other disciplines. And that's why it becomes digital. And with SysML2 which is the rehash of SysML that they're doing in OMG, part of what that is about I think, creating a framework where that can exist, that should actually help support that digital aspect and support digital engineering. So I don't think you can really talk about MBSE without talking about digital engineering, about having that oversight about how you're actually going to deliver the project in terms of all the tools and planning that. That's almost as important. You've got to have that in place. It's almost as important as the thing that you're going to produce. That's the way I see it.
Yeah, I completely agree. And I think that development for SysML2 agreed as well. It's a move in the right direction. So yeah.
So for those who might not know, SysML is the systems modeling language. It is a language that you can use to undergo your modeling, your approach to MBSE. And SysML has been around for a few years now. It's derived from the Universal Modeling Language, UML, which is a very commonly used one, but with a bit more supposedly applicability to systems. And SysML 2.0 is in the works, and I'm led to believe is reasonably imminent.
Yeah, I would make a caveat. You don't need to know SysML to do model-based systems engineering. Okay, model-based systems engineering exists in all domains, anywhere that you've got somewhere where they've got electronic models or digitally captured models of something or other. Okay, SysML gives you a way to abstract that, but I think it gives you a data framework more than anything else. So I've been doing a lot of stuff with BIM, which is building information models, which is basically 3-4D CAD, and all the stuff that you can do with that is fantastic if you get the right structures in place. And that's another way that you could start to think about doing model-based systems engineering. So don't just think about it as SysML. That's the other thing. It's huge.
Yep.
That's why I find it so fascinating still.
Yeah, agreed. And that's the thing. So the languages kind of are developed, but the actual concept of MBSE is much broader, obviously, than that. So we can get hung up about kind of SysML versus other languages, but ultimately what we're trying to do is model systems to add value in whatever context we're using it, and really being clear on where that value is something that we see as being absolutely fundamental. If you don't understand why you're doing the modeling, then you need to challenge why you're doing it in the first place. Okay.
Great. You've brought up a rather interesting diagram of a life cycle here.
Would you like me to talk through that?
Please do.
You've got some questions. Yeah. So this is just a generic life cycle for a system. So recognise there'll be information potentially missing from this, but it's just there to try and provide a bit of a framework to explain some of the benefits of MBSE. And we see kind of that yellow golden thread throughout the life cycle of the program, both in terms of system development, but also through life, where MBSE has a role to play potentially to support the system development. And that all comes down to what's the purpose of your system, what's the context in which the program is needing to deliver it. But typically an assumption would be MBSE has the potential to support the system throughout its life. So starting off with looking at some form of OA, operational analysis, driving systems thinking techniques, and deriving top level requirements for the system capability that's needed. You can apply models, as Graham pointed out earlier, to develop that view of and analyze the requirements to elicit decisions from the right stakeholders to drive some of the characterization of what your problem space is for the system, and use that to be a basis to develop system requirements. So that can be modeled. There's different approaches to doing that, but you would typically take your system requirements and go through and elicit and develop your architecture and the requirements iteratively, and use and follow model-based approaches to do that. So you could do kind of requirements and architecture modeling. There's various tools that are able to do that, and then the outcome of those, it depends on the approach. So again, this is where agreeing up front how MBSE is to be done for a program is really key, because there's lots of different ways in which it could go, and this is where programs of complex nature, such as the one that I'm working on, but there's various programs that are out there. That's such an important thing to define up front, particularly when you have several organizations working together on those complex programs. So interfacing between the different domains, interfacing between different partners, developing the same model and managing all of the data throughout those life cycle stages, and with the different kind of disciplines that are involved along the way. There's a fundamental data management activity capability that's needed to support the overall kind of MBSE work, but this kind of broader blue V kind of captures, if you like, the other digital engineering work that maybe sits technically outside of the MBSE scope, but has to interface with MBSE. So MBSE provides that handrail throughout the life cycle of the program, and supports the different capabilities that feed in at the various stages of the life cycle. So hopefully that just provides a bit of context for how holistic we need to be thinking within the technical space. There's a load of non-technical considerations that we also need to consider. We've got commercial, security, enterprise program management stakeholders that also will need to engage with the technical community. So how do we communicate our models for stakeholders without kind of scaring them too much with SysML diagrams and such like? How do we ensure that the value of these models is being realized across the program and not just within the systems engineering community?
Speaking of the value, where have you seen that value come through the most on the projects you've been working on?
I think there's an opportunity around being able to manage risk and be able to gain insights from system development and how mature the system modeling work is progressing through a program. So being able to link programmatics to the modeling activities, is one example of where you've got enterprise program stakeholders interested in the models that are being developed. I think there has to be, the model is the thing, is the work that we're doing. It's not a model that sits on the side and we're doing our engineering work. It's separate to that, and the model keeping up with the work. The work is being done within the model, and therefore we can understand where we are with the model if it's set up in ways in which we can be feeding that data back. The requirements validation and being able to de-risk and ensure we've got better quality requirement sets and improving the requirements in architecture work up front to reduce, as Graham was pointing out, the defects later on in the system development. So left shifting risk, but also left shifting the identification of defects saves an awful lot of time and money. And then when it comes to the kind of the through life benefits, you could have maintainers, operators, people responsible for supporting the system through life, also using the data that's being developed from the model. So yeah, there's various benefits. It's just thinking, how ought we be setting up our models in a way in which will serve the various value networks that exist.
Conversely then, are there any, what's been the big ticket items that you've struggled with when it comes to applying MBSE in this context?
I think with any complex program where there's different networks potentially being used or different organizations involved, I think there will always be challenges around commercial IP and data, and how model development respects company IP, but at the same time, and security, and how do we square that kind of collaborative approach to doing model-based engineering with the kind of the hard legal frameworks that exist at the moment, and how can we, for instance, potentially be using models to generate requirements, and how do we communicate those between partners? Commercial arrangements, from my experience, don't typically use model artifacts; they use text contracts. So how can we square the model development, communicate requirements in a model-based way, but also kind of satisfying the needs of non-technical stakeholders that exist on programs?
So that was one of the big things that we were working out near the end of my period with IBM. There was a lot of work we were doing with people like Daimler and Bosch around how you get that handover and those interfaces. I don't know where it ended up in the end.
Yeah,
but the requirements requirements and models need to be handed off together. But I think we were also looking at maybe doing something around blockchain and using the blockchain to actually give you secure access to different parts of the model depending upon rights and stuff like that.
Interesting.
And it becomes a very That's one of the things that we were working on. I was working on about 6 or 7 years ago.
Wow.
But I don't think it ever. That's when blockchain was a bit of a buzzword. That's certainly an application that could be applied to that sort of problem.
It's a really interesting application because it's in the sort of circles I run in. It's a bit of a dirty word when you think of blockchain and NFTs. It's all about the commercialization of it, but it's interesting to think it could actually have some security strengths in the application for MBSE.
There's lots of potential around.
Yeah, blockchain is so much more than just being used for crypto. There is so much more. They use it. So IBM were using blockchain for it's for provenance of vegetables going across Europe. Okay, and if you really wanted to do it, it basically would solve the Northern Ireland problem if they could get their act together. It would, if you could digitize everything that's going across the customs border between UK, Northern Ireland, blockchain would do that easily. But it's
distributed ledger kind of
it's that distributed ledger technology.
Interesting stuff.
But seeing how kind of structuring our engineering work with data being at the kind of the fundamental core of it, how we can be leveraging other technologies to enhance how we do things. And I think there is a wider digital transformation across engineering that offers up all of these interesting opportunities. We've not touched on, and I don't propose we do in this forum, but what does machine learning and kind of broader AI kind of capabilities and technologies, how does that potentially play into how we transform how we do engineering? It's a really interesting area. And again, MBSE being at the heart of digital engineering, we need to be considering these opportunities and making sure we're not missing out on areas where we can be improving.
I mean, I'll give you another example of where that in IBM we were doing. So we were looking at not so much meaning, but it was NLP language, natural language processing. And we started to do it for requirements, looking at requirement structures. But then I also had the idea that basically you could take a concept of operations document, and providing you understood the domain and what it was mapped into, and we mapped it into like UPDM, UAF meta model, you could basically look at a document, run it through an NLP, and you could use that to give you a first cut of your architecture.
So it's translating between language domains, really. It's being able to take something from text and feeding it into kind of different ways of representing the data.
Yeah, and me and my colleague, we spent an afternoon just messing around with the toolbox that we got from IBM. But we got this 60-page PDF document had concept of operations for search and rescue, I think it was, or lifeboat operations, whatever. And it turned it into, we dragged it into Rhapsody, got it into as a model, mapped it into a fairly simple meta model, but it actually made sense. Okay, and that took like an afternoon of work, which was mainly about formatting the document, formatting how we processed the document formatting. But the actual processing looked like it took about 2 minutes, and that was against a fairly generic thing. But I was amazed that the model made sense, and I was gobsmacked by it. There's huge potential there. So it's MBSE. It's like we're just starting to scratch the surface of what we can do with it.
Yeah, that's it. And touching on even automating some of those mundane activities, such as document generation from the model. Again, is doing MBSE in certain ways, creating the right structures within your model to be able to automate generation of documents or artifacts that serve the needs of the stakeholders that are interested. And I think that there's a broader kind of there's model management skills that I think we need to be developing across industry to be able to support the kind of the robust approaches to MBSE that are needed. There's the modeling skills that we need to develop and understand, okay, there's automation in various areas that we could be driving to get some quick wins. But I think in general, because the kind of the industry and how we do things is evolving so quickly in areas, that we just need to collectively need to continue kind of being open to learning and embracing change, because it's happening at quite a rate at the moment.
That ties in quite nicely to a question that Charles asked earlier, which I see Graham's already answered in the chat, but he was asking, is Incozy UK looking at the role of AI and machine learning? I just wondered whether that was anything you had any thoughts on, Geoff, maybe not from an Incozy perspective, but from a user.
I think, you know, AI offers a really interesting opportunity. I think, you know, how humans and AI work together on engineering problems, I think, is something that is really exciting and does offer a lot of really interesting opportunities. I'm not going to claim that I'm an expert at all. I've like, I think pretty much everyone I imagine on the call has been on ChatGPT and learned a little bit more about kind of how we can be interacting with AI more, but I'm by no means an expert, but I have the suspicion that we'll need to be kind of defining ways of interacting with AI appropriately, and you know, understanding, you know, what the role of automating aspects of what we do and using the benefits of AI to improve and enhance our collective capability. We could be training kind of models within enterprises potentially to kind of improve our efficiency of developing concepts, for instance. But yeah, I'd definitely be excited to learn a bit more about, and when people have thought about it a lot more, to see what they think about the intersection between AI and how we do our engineering moving forward.
No, thank you for that.
There's certainly room for that, for being another working group. That is basically another working group in its own right.
Yeah, but the teaming up of AI and humans in order to improve our effectiveness on solving engineering problems and developing solutions is, I see that being the thing. I don't think it's going to replace us as such. I think there's that creativity that humans provide in the lateral thinking and context, but I think AI has huge value add.
I think there's your answer, Charles, is if you want Incozy to be doing more on AI and machine learning, perhaps you can be the one to start an interest group. I believe that there have been papers submitted to Incozy UK before, white papers on topics of AI and machine learning. So they'll most likely have been published on the Incozy UK website. So I would check there as your first call.
Yeah.
Does anyone else have any questions whilst they're still here? Does anyone want to come off mute if they've just thought of anything? If not, we can go to what's in the chat, but just wanted to give people the space to do that. Okay, no worries. Appreciate we've officially hit the end of the meeting, but Graham, Geoff, are either of you okay to hang on just for a couple more questions that are in the chat?
Yeah,
definitely.
no problem. Yeah.
Okay, great. Anyone else who's attending, do feel free to drop off if you've got other commitments, but we'll probably hang on for 5 more minutes or so. So Graham, again, I see that you replied to a question around so the question was, from your experiences, how do you use the model as a communication tool in an organization if stakeholders don't understand SysML? So I'd like to broaden this out to, perhaps, if I may, how do you communicate the artifacts and products of your MBSE to people who aren't as literate in it, regardless of what language that is? Yeah.
So generally what I've seen companies do, and MBDA were really good at this, they created a structured set of courses that had various levels of maturity of people. So certain people, they did a reader's course. So it's basically, you just need to review a model. What does it look like? Okay, and it went through the notations and the diagrams that they were going to use, so that people got an understanding for it. And another level, they had a modeller's course, which is that they were basically getting in there and they were actually doing stuff. and then they had a much more advanced one, then had a very advanced one, which was setting up meta models, setting up the tools and the processes around it. But I think you certainly need a reader's course in there to give people an indication about what is going on. But I mean, I found it when I first got involved with it, it's basic block diagrams, or it's sequence diagrams, or it's a flow chart. It's a variation on those three diagrams. Basically, if you can understand those, you've pretty much got most of what SysML is. I think the key, though, is getting the idea that everything is connected. It needs to be connected and consistent. And that's the key to having a good model. Because if it's not connected and consistent, you're going to have a load of errors.
Yeah, the idea of authoritative sources of truth driving views across the enterprise and not having data copied and pasted in various parts of it. So yeah, the connection of models, and whether those models, you know, maybe come from data that was kind of developed within an MBSE environment, but actually the data is being seen on a program dashboard elsewhere, and actually the stakeholder has no real interest in the MBSE diagrams, but there's elements of that can be connected up within their own familiar kind of way of viewing things.
Yeah, I normally go
stakeholder requirements on the model, if you like.
Yeah, basically data needs to be consistent, correct, and complete. And that's quite hard to do, but even getting it halfway there, you're better off than you were with your Excel spreadsheets.
Definitely.
Yes.
Yeah.
Yes. No, very true. And Geoff, have you encountered any issues in your work with stakeholders struggling to understand aspects of a diagram and you having to explain that?
Yeah, it was a really interesting conversation I had with it was actually, it might have been Simon Perry who you mentioned, Graham, a little while ago. So he does quite a bit of MBSE training. We were having a session with him about a year or so ago, and he mentioned there was you would often kind of come across stakeholders when we show a diagram or, you know, a view of the model on the screen, and you know, we deliberately simplified the model so that people can digest the information. So it kind of almost gave the sense that the system being developed wasn't that complex, or you know, you couldn't really appreciate the complexity of what the system being developed was. So he kind of pulled together, or I think a program that he was involved with or supported, put together almost a shock and awe diagram, they referred to it, and it was all of the interfaces, all of the traceability between the elements. And the intent of the view was not to understand the system itself, it was to understand how complex the overall system was that they were developing. So really getting that the message was to stakeholders not familiar with the model or the system being developed, how complex the work was. So it was a really effective way of doing that. And I think, you know, when we present our models, we need to present them in a way that can easily communicate a point or serve a clear purpose. But it can't be kind of ignored that the collection of these views, the definition of your system model, will inevitably be complex. So it's how we carve up the complexity in a way that makes sense. And I think in addition to that, I think there's how we work in modeling teams being a real challenge. I think, you know, there's collaboration, model management, configuration management, information management. There's loads of, these are really broad topics that you could spend a lot of time diving into each of them. But there needs to be appreciation for how nuanced and complicated models can get, and there's a real overhead potentially, if not managed effectively, being able to kind of ensure that we're developing models in an appropriate way so that it is potentially going to be certifiable, or, you know, we can demonstrate that traceability in a consistent way and trust the model that we're developing. So there's an awful lot of discipline and management involved in collectively developing a model.
Yeah, I think discipline is quite a good way of putting it. From my limited exposure, it's one of those things where when you're creating, you've got your model, but you create views for different stakeholders, and part of the discipline is making sure that those views are only showing what is necessary, particularly to someone who isn't trained in MBSE.
Yep.
You you take a lot for granted when you've been working on something. You create shortcuts in your mind, you understand how things work, and every time you're presenting this to a new group of stakeholders, they're people who've never seen this before. And you need to make sure you are only presenting the absolute bare minimum. I think Simon, who you mentioned, he says he tries to avoid having more than, what was it, eight or nine things on a diagram.
That's probably 7 plus or minus 2 again.
Exactly.
That rule. Yeah. And yeah, it was a different program, but and not one that I was working on, but I was aware of, models being developed potentially without clear descriptions of the views, or what the purpose of an aspect of the model was. And I think it's so important. We touched on kind of knowledge management on programs, and the real challenge of knowledge management on particularly complex programs where no one person can fully understand everything. And actually, with people moving in and out of projects, how is knowledge managed on a program level? There needs to be a kind of coherent approach to how we ensure that the model is actually capturing the knowledge, and people are able to get up to speed on programs, and also how do we communicate and develop the model in a way that's coherent, as you say, Graham, meeting all of those criteria. There's a huge part around ensuring that we're not cutting corners when we're developing models, where actually it may seem tedious to the person who knows everything about that particular aspect of the system, but communication is so important on programs, and often gets referred to in sessions like this, but we can't understate the importance of effective communication across not just your own kind of team and systems engineering community. It's with everyone who has an interest, and the stakeholders identified for your part of the model, and making sure that it's satisfying the needs that they have. And if we're not sure on what the needs of those stakeholders are, then we go out and find out.
Yeah, I mean, it's some really interesting points. So when it comes, you talked about document generation, okay, model-based document generation, completely agree with it. Okay, it only works basically if you fill in the description for pretty much every element on that model, and I can assure you it's one of the model measures or quality checks that we used to do, run on one of the checkers we had in Rhapsody, how many had a description, and quite often you'd find there'd be no descriptions in anything. Okay, that's a really good catch. If people have started to put descriptions, and they're good descriptions in there, that's starting to be a sign of a good quality model. And I tell you, the other issue that I've learned over the years is configuration management. That model management, configuration management piece is key, and that's not just for models. It's basically about anything. It's normally considered far too late in any program, but it should be underlying your processes right from the very beginning. How you're going to understand configurations, different versions of things, and how you're going to manage them. And
on that bombshell, Graham, I think we'll call it there.
Yeah, I know, it's been interesting.
Been some really good discussion. I really appreciate the engagement people have been giving in the chat. Some really good stuff.
Yeah.
It's really good to see there's so much interest in all of this. Oh, Charles, you're putting your hand up.
Yeah, just to say to Graham, mention CM. Absolutely.
Configuration management.
Yeah, you sound as though you've been through a few wards of that.
You're absolutely right. Good presentation, guys. Enjoyed it.
Thank you.
Yeah, really thank you both, Geoff and Graham, for making the time to put material together and to share your thoughts and your war wounds. And apologies again, Graham, for cutting you short in your presentation.
All right,
but we'll make sure
I would have cut it shorter if I'd known.
Perhaps a part 2, Graham.
Perhaps a part 2. We'll make sure that's distributed to the rest of the ECF.
Yeah,
sure
and it's got my email address if anyone's got any at the end of it. So if anyone's got any questions. Yeah,
fantastic.
Yeah.
All right, everyone. Well, I will let you go.
Okay. Thanks very much.
Thank you for sorting, Nathan.
Bye.
Cheers. Thanks, Nathan.
Thank you, everyone.
Bye.
Bye, Fraser.